morning. Today we are going to see hashing in data structures and algorithm. Hashing is a technique that converts a range of key values in a range of indexes of an array. For example, if you are going to convert a phone number into a smaller number, for example, phone number may be a 10-digit number. If you are going to convert into a 3-digit or 4-digit number, then only we can fix it in the hash table. So the smaller number as index in a table is called as hash table. For example, if you are going to convert a 10-digit mobile number, for example, if a class of students having 60, for example, 80 students in a class, each one having 10-digit mobile number, we want to fix it in a length of 80, table size of 80, we have to use the small indices number. For example, last 3 digits of the phone number. So that's called as hash table. Hashing is a solution that we can be used to almost in all situations, perform exactly well when compared to other data structures like arrays, linked list, AVL, etc. Hashing is will be performed better than these type of data structures. With hashing, we can get O of 1 search time on average and O of n in worst case. So for example, in a manufacturing company, they are having an inventory file that consists of less than 1000 parts. So each part having a unique 7-digit number. So the number is called a key, and particular key record consists of that part name. For example, in a company they are manufacturing, for example, if they are manufacturing a chip, each chip having a unique number. That unique number is a 7-digit number. We have to fix in a table size of 1000. We have to fix the 1000 chips in that table. So if there are less than 1000 parts, then 1000 element array can be used to store the complete file. Such array, the 1000 means it can be indexed in an array from 0 to 999. So since the key number is a 7-digit, that for example for the chip key number is 7-digit number, so we are going to convert into a 3-digit number by taking the last 3 digits of the key value. So for example in the figure below, so first position, so the 0th position, how we are going to calculate like this, we take the key value and take modulus 1000. The last 3 is the remainder. For example, first number is 4967 000. If we take modulus of 7, then the value, position value will become 0. So the first value will be inserted in the 0th position of the key. Like that, second, for example, 8421002. So we take modulus of 1000, we get 002. So it will be comes under the index position 2. Like that, similarly 396, 4618396, modulus of 1000, it will becomes 396. So it will be inserted in the 3 indices of 396. So likewise 397, 399. Next, then 990, last number is 999. So the 1000 chips, each one having 7-digit number. So our table size is 1000. So the key, h of key mod 1000. Each number is taken modulus the 1000. We get 3-digit value. So if the last digit is 0, it will be stored in 0th position. Last digit become 1, it will be stored in 1 position. Likewise, 100 means 100 position. Likewise, 999, it will be stored in the 999 position. So this is called as a hashing. The values will be stored in the respective hash table. So this is shown in the first value is 496700, and it is stored in the 0th position. Then 8421002, it will be stored in the second position. Likewise, it will be stored 397th position. So the function that converts key, that 7-digit key, into an array position is called as hash function. So this method of searching is called as hashing. So we are searching the key element with the help of hash table and table size. We can convert the we can fix it in the array position using the hashing. that for example the hash function is for that particular example is h of key equal to key mod 1000, where key mod 1000 will be the hash function and the key obtained by the hash function is called as hash key. So hash function, what is hash function? So a function that maps bigger number into a smaller integer that can be used to index in hash table. This is called as hash function. For in the previous example, we taken 7-digit number. Using the hash function, we are converting into a smaller digit number. It will be fixed in an array. This is called as hash function. Hash function is a function that is used to place in the hash table. Similarly, hash function is to retrieve the data from the hash table. So hash table is used to place the data in the hash table as well as retrieve the data from the hash tables. So the use of hash function is to implement the hash table. So hash function is mainly used to place the data, retrieve the data and implement the data. So then what is hash table? Hash table is a data structure used for storing and retrieving data quickly. So for that only we are using hash table. Every in the hash table is made using the hash function. So say empty. For example, in the previous example, it's a table size of 1000 values. It's a empty table. Using the hash function, we are fixing every value in the particular table. So the table size is 1000. So the value may be below 1000 or exactly 1000. Less than or equal to 1000 only. That's the size of the table. So let us take an example. Consider the hash function as key mod 5. So here we are having a hash table of size 5. In this example, how we are going to insert the 5 values in the hash table. Step 1. First we are going to insert 33. So the table size is 5. So 33 mod 5. The remainder is 3. So the 33 will be stored in the table in the third index. So the 33 is called as bucket. So next step is the 33 mod 5 is called as hash function. Next step is we are going to insert 54. 54 mod 5 is remainder 4. So 54 is stored in the fourth index of the hash table. Then next step is we are going to insert 25. 25 mod 5 0. So it will be stored in the 0th index. So this is the example for how we are going to insert the value in the hash table. So what is bucket? Already I told. Hash function h key is used to map several dictionary entries in the hash table. Each position in the hash table is called as bucket. So the entries we are entered in the hash table, each entry is called as bucket. So collision. So the main topic in hashing is called collision. The situation where newly inserted key maps to an already occupied slots in the cache table is called as collision. Collision is when a hash table in a single index, 2 entries occupying means called as there a collision occurs. So we see one example. So collision is a situation hash function returns the same address for more than one record. So in the previous example, already 25 in the 0th element. Now we are going to insert 55. So 55 mod 5 is 0. So already 0th position having 25. Already 25 is occupied. So we are going to occupy the same 0th position. So 25 and 55 occupying the 0th index. So collision occurs there. So how to resolve collision? So we have 4 collision handling techniques. First one is separate chaining. Second one is open addressing. In open addressing we have 3 methods: linear probing, quadratic probing, and then double hashing. And third method is rehashing. Fourth one is extensible hashing. So first method is separate chaining. So the separate chaining is a method that uses linked list to store the records. For example, the same example we are going to for all the collision handling technique. Let us consider simple hash function key mod 7. The values are 50, 700, 76, 85, 92, 73 and 101. So this is the table size. 0 to 6 is the table size. First we are going for separate chaining. First value is 50. So 50 mod 7. So it will be in the index 1, 50. So then the second value is 700. 700 mod 7. So it's in the up by the 0th position. Next value is 76. third value is 76. 76 mod 7, 6, it occupies the 6th position. Then 85. 85 mod 7, remainder 1. Already 50 in the index 1. So it's a linked list. So we link 85 also with the index 1. Likewise 92 also occupy first index. So 92 also in the index 1. So then 73 mod 7, the remainder is 3. So it will occupy the third table's index of 3. Likewise 101 mod 7, remainder 3. So after 73, 101 comes. So this is a linked list. Every value after taking the modulus of every hash value, it will be linked with the same index value. So what are the advantages of separate chaining? It is simple to implement because each and every value collision occurs. Each and every value is separately occupied the linked list. Hash table never fills up because the table size is 7, but in some index 1 we have 3 values, index 3 we have 2 values, so the table will not be filled. The elements are showing like a chain, like electric train, like the train. So less sensitive to hash function or load factors. It is mostly used when unknown how many and how frequently the keys may be inserted or deleted. Like that, this method is used. So the cache performance of chaining is not good because more values are stored in a single index. So open addressing provides better cache performance. So only we are moving from separate chaining to open addressing. So wastage of space. Some of the indices 2, 5 are never used. So wastage of spaces are there. The chain becomes long. Some of the, for example, in our example, in one we are using 3 values in the same index. So the chain becomes long. The search time becomes O of n in worst case. It uses extra space for the link. So there are a lot of drawbacks in separate chaining. For that only we are moving to open addressing. So in open addressing, the table size must be greater than or equal to total number of keys. For example, if we are going to insert 7 keys, the table size must be 7. So the table size must be greater than or equal to 7. So if we insert, so the keep probing until an empty slot is found. One empty slot is found, we are going to insert the k value. Likewise search, keep probing until slot key does not become greater than or equal to k or an empty slot is searched. For deletion also we are using deletion operation is interesting. If we simply delete a key, then search may fail. So slots of deleted keys are marked specially as deleted. So insert can insert an item into a deleted slot, but the search does not stop at a deleted slot. So in first method is we are going to see linear probing, in which the linear probe find the next free slot. For example, a gap between 2 probe is 1, as taken below as example. So we are going to use the hash function. Let us take hash of x be the slot index computed using hash function and s be the table size. First if slot hash of x mod s is full, then we are going to try hash of x plus 1 mod s. If hash of x plus 1 mod s is also full, then we are going to try with the hash of x plus 2. Likewise it goes on. If the hash of x plus 2 is mod s is also full, then we are going to try until the free slot, until we find the free slot, it will be continuing. So let us take the same example. So we take key mod 7. We are going to insert 50. First we are going to insert the 50. So insert 50 hash of x mod s. S is the table size. Our table size is 7. 50 mod 7 equal to 1. So we are going to insert 50 at the index 1. So in the table at index 1 we are inserted 50. So next value is 700. So we are going to insert 700 as the next value. So insert 700 hash of x mod s, 700 mod 7 equal to 0. So we are going to insert 700 at index 0. So insert 0, 700 is inserted. So the third value is 76. Now we are going to insert 76 hash of 76 mod 7 equal to 6. So insert 76 as the index 6. At index 6, 76 is inserted. Next we are going to insert 85. So 85 mod 7 equal to 1. So we are going to insert 85 at index 1. So already in index 1 we are having 50. So 50 and 85 are both 50 and 85 sharing the both at index 1. So the collision occurs here. So once 50 and 85 sharing the index 1, collision occurs. So hash of x mod s is full. Then we are going to try the next formula, hash of x plus 1 mod s. So 85 plus 1 is 86. 86 mod 7 is equal to 2. So we are going to insert 85 at index 2. Now the collision is resolved and 85 is inserted at the index 2. So next value we are going to insert 92. 92 mod 7 is 1. So already 50 is at the index 1. 92 also inserted at 1. So we are having a collision. So 50 and 92 both are at index 1. Collision occurs. So already hash of x mod s is full. Then we are going to try the next one, hash of x plus 1. So 92 plus 1 93. 93 mod 7 2. So we are going to insert 92 at the index 2. So in index 2 already we are having 85. So 85 and 92 are both at index 2. So then we have collision occurs. So a hash of x plus 1 is also full. We are going to try hash of x plus 2 mod s. So 92 plus 2 94. 94 mod 7 equal to 3. So we are going to insert 92 at index 3. So 92 first inserted at 1. Then using the hash function it is inserted at 2. Finally the collision is here also we have collision. Then collision is resolved. Now we are inserting at 92 at index 3. So next we are going to insert 73. 73 mod 7 equal to 3. So we are going to insert 73 at index 3. So already index 3 having 92. So 92 and 73 both are using index 3. The collision occurs. So we are going to use the formula hash of x plus 1. Already hash of x mod s is full. So 73 plus 1 74. 74 mod 7 equal to 4. So we are going to insert 73 at index 4. So now 73 is inserted at index 4. So now we are going to insert the last value 101. So 101 mod 7 equal to 3. So we are going to insert 101 under index 3. Already index 3 contain 92. So there we are having collision. Collision occurs. So 92 and 101 are both in the index 3. Collision occurs. So we are using the next formula hash of x plus 1. So 101 plus 1 102 mod 7 equal to 4. Now we are going to insert 103 at index 4. So already index 4 contains 73. So 73 and 101 are index 4. Here also collision occurs. So now we are using the next formula hash x plus 1 mod s is also full. Then we are going to try hash x plus 2 mod s. So 101 plus 2 equal to 104. 104 mod 7. 104 mod 7 equal to 5. So we are going to insert 103 at index 5. Next. So now 101 is inserted at index 5. So this is the method we are using hash function. When hash of x mod s is full, we are going to use the formula hash of x plus 1 mod s. When hash of x plus 1 mod s is also full, then we are going to use hash of x plus 2 mod s. So finally we are inserting every value in the table. Next slide. So here all values are inserted in the hash table of size 7. So in 0th index we are having 700, index 1 we are having 50, index 2 we are having 85, index 3 we are having 92, index 4 we are having 93, and index 5 we are having 101, and index 6 we are having 76. Next. So in quadratic probing, we look for the second slot in the ith search. For example, in the previous example, linear programming, we are using hash of x plus 1. Here only one change. Instead of hash of x plus 1, we are going to use, if hash of x mod s same, if it is full, we are going to use hash of x plus 1 star 1 into 1 mod s. When hash of x plus 1 star 1 is also full, then we are going to write hash of x plus 2 into 2. In previous exam method, we are using hash of x plus 1. Here we are going to use hash of x plus 1 square. If hash of x is full, we are going to use hash of x plus 1 square. If 1 square is also full, we are going to use hash of x plus 2 square. 2 square also is full, we are going to use 3 square. Only formula is changing. So we are taking the same formula. So first is 50 mod 7, it will be inserted at 1. 700 mod 7, it will be inserted at 1. And then 76 mod 7, it will be inserted in 76. Then come 85. So 85 mod 7, already we see it will be collision with 50 and 85 are sharing the index 1. So then we after using the formula, so it moves to index 2. Then we are inserting 92, we also collision occurs. So when using the formula, then 85 and 92 shares the same location. Then after using the same formula, 92 is inserted at insert 5. So likewise 73 shares the index 3, and then 101, when we are inserting 101, we occurs collision. So using the formula, 101 is inserted at position 4. So this is the value after storing the using this method. After we are this is the final value. Only I am showing the final value. Next method, double hashing. So double hashing is little bit difficult when compared to previous two methods. In this method, we are going to find the second hash value. For example, we are finding hash of x be the slot index computed using hash function. If hash of x mod s is full, then we are going to try hash of x plus 1 into hash 2 of x mod s. Then how we are going to find hash 2, 1 into hash 2 of x is also full. Then we are going to use instead of 1, we are using 2 into hash 2 of x. If hash of x plus 2 into hash 2 of x is also full, then we are going to use hash of x plus 3 into hash 2 of x. How we can find the second hash function? So here hash 1 of key equal to key mod table size. The table size must be greater. If the original table size is 7, then the second, for using the second hash function, the table size be less than the 7, but it might be a prime number. So the popular second hash function is h2 of key equal to prime minus key mod prime. So if for example we take 7 as our table size, we are going for second hash function. Our the prime number may be lowest than the table size 7. So then our prime number may be 5. So then we are going to, for example, we are going to find hash 2 of 85 equal to, what is the prime number? We are going to use 5. 5 minus key is 85, key mod 85. For example, our prime number is 5. 5 minus key mod prime. For example, we are taking 85 means 85 mod 5, 0. So hash 2 of 85 becomes 5. The good second hash function is it must never evaluate the 0, must make sure that all cells can be propped. So let us take the same example. So when we are inserting 50, 776, no collision occurs. When we are inserting 85, a collision occurs at 50. So then using the second hash function and further calculation, it will be 85 will be moved on to the index 4. And then we are going to insert 92. 92 will be a collision. There will be a collision occurs between 50 and 92. Then using the second hash function and the formula, 92 will be inserted at index 3. Then we are going to insert 73. 73 and 92 we are having a collisions. So then 73 will be moved to index 5.
then 101 will be inserted at index 3. This is the final value using problem. Thank you.